Hey, and welcome to the video. In this video, I'm going to demonstrate a cool routing concept called router redistribution. First of all, if you look at our topology, our scenario is basically this. A NASA-based company has recently acquired two companies on the Family Islands. One company in Exoma and one company in Albuquerque. We've already had our lease lines run and we're ready to go. The only problem is, the company in Exoma is already established with the routing protocol EIGRP, and the company in Abaco already has their network established using OSPF. NASA now needs to find a way to redistribute EIGRP traffic and inject it into this OSPF domain. NASA also needs to find a way to redistribute OSPF traffic and inject it into this EIGRP domain, because Exoma can only understand EIGRP and Abaco can only understand OSPF. The concept of router redistribution is that simple, a way in which we allow two dissimilar routing protocols to communicate by appearing as though they're all on one homogeneous routing protocol. To begin, I'm going to show you the routing table of the NASA router so we can see what NASA knows. And if you look at the routing table, you can see that NASA has a pretty clear picture of the way the network environment looks. It can actually reach everyone. It has OSPF running on one side of its interface, and that's the interface that's connecting to Abaco, and it has EIGRP running on the interface that's connecting to Exoma. So it's learned about some EIGRP routes, it's learned about some OSPF routes. So NASA is what we'll say is fully converged. And this is the router that we'll actually use to redistribute routes between Abaco and Exoma. If you look at the Exoma router, however, Exoma doesn't know much. Exoma actually only knows, let me just clear the screen a bit. If we do a show IP route, Exoma only knows about EIGRP stuff. You only see D and C. D is for EIGRP and C is for directly connected. Likewise, if we go over on the Abaco side, Abaco only knows about OSPF stuff. So if we look inside our routing table, you see that OSPF only knows about what's on its side, 192.168.2.0 and 172.16.20.0, because that's what's directly connected to it. It didn't need to learn any routes from its OSPF neighbor because everything is directly connected, and that's just the way OSPF behaves. So what we need to do is go inside our NASA router, and ultimately the goal is to allow PC1 to actually ping PC2. PC1 has an IP address of 192.168.1.2 and PC2 is 192.168.2.2. If we try to ping right now, we will get an error. Alright, I tried some pings earlier, but if we try to ping right now, it should say destination host unreachable. And all that means is that the reply from 192.168.1.1, which is the router doesn't know how to get there. If we try to ping from PC2, we'll get the same message. Apply from 192.168.2.1, destination host unreachable. All that means is this router right here, which is 192.168.2.1, doesn't know anything about the one network. So let's get into it. If you go inside the NASA router, configuring router redistribution is very simple. Firstly, we go into global configuration mode. Then let's start with EIGRP. Let's go into router configuration mode with EIGRP. We're going to use the command redistribute, and we're going to say redistribute OSPF with the process number of 1, and we're going to put in some metric information because EIGRP needs to know the best path to get to its neighbor, so it uses the metric to find that out. So the metric must be defined in the redistribute statement. So you have bandwidth, let's just say our bandwidth is 128K. EIGRP delay, we could say 0, there's no delay on this link. Reliability, you could say it's 100% reliable. Load, there's not much load, so we'll put a 1 there. And we can just put in an MTU, the size of the packet, say 1500. And that's it for redistributing OSPF into EIGRP. Next, let's redistribute EIGRP into OSPF. So we type in router, OSPF1, we use the redistribute command, and we will type in EIGRP and the process number 100. And we can sum it up by just typing in subnets, and we'll leave everything else at the defaults. What this will allow us to do is redistribute all EIGRP subnets into the OSPF domain. And that's it. We can save our config, and we successfully configured the router redistribution. Now here's how it looks on each router's console. If we look at the Abaco router now, if we look at the routing table, we see that Abaco has now learned about some external routes that it didn't know before. And these routes are recorded as external type 2 routes. So Abaco now knows how to get to 192.168.1.0, and also knows about the link that connects Nassau to Exuma. So Abaco is now fully converged. If you look at the Exuma router, and we type in show IP route, you see that Exuma now knows about some external routes as well. It now knows how to get to 192.168.2.0. So when traffic comes from PC1 over to the Exuma router will know where to forward that traffic. The amazing thing about router redistribution is it doesn't allow the routing protocols to commingle. It actually behaves as though the environment is simply a homogeneous environment, and there are not many different routing protocols, because from Exuma's perspective, all it knows about is EIGRP. Even though redistribution is complete, it's still, all of the routes that it's learned, it's still represented as EIGRP routes. Likewise, on the Abaco side, Abaco only knows about OSPF. All of the routes that are represented in the routing table are simply OSPF networks. So if we try to ping now from PC1, PC2, we should get successful replies. And there we have it. So our network is fully converged, and that is a brief introduction into router redistribution. We can get more complicated than that using route maps and all of that, but this is the basic fundamentals of what router redistribution is, how the concept works. If there are any questions, don't be afraid to ask me on the website, kennynotes.com. Let's get in some constructive dialogue with what we've learned, and keep sending on your questions via email, and I'll keep creating the videos to tailor what it is you want to learn. I hope this video has been informative for you, and I'd like to thank you for viewing.